Hello and welcome to the COVID-19 Inspire Hackathon Finals. We are today going to have the pleasure of learning about the results from this very relevant series of challenges. My name is Bente Liabi. I am going to be your host today, and I'm also a member. I'm a member of Plan for All, the committee of Plan for All, and I have been involved in many Inspire hackathons. But it's a special pleasure today to present to you all the results from the COVID-19 Inspire hackathon. With me today, I have the jury members. I will invite the jury to present themselves. Can you come on camera, please? Yeah, hello, Beata, Joanna, Maris, and we will see also Joseph. We have quite a bit of a program. I will show you that shortly. But before I will ask the jury will, of course, they have read all the reports from the challenges, but today they will also evaluate the presentation, and the excitement is big to present the top 3 teams. In addition to that, in addition to the jury, so be prepared. In addition to the jury, we will ask you, the audience, to have the popular vote for your favorite challenge. So there will be the results from the jury and also the popular vote from the audience. So we hope that you will participate in this. Hello, I see that there are many coming in here. Hello, Christina, Monica, Herman, Sarah, Paolo, Vincent, Hannah, Pavel, Jacob, Elias. I read as fast as I could. Very great to see all of you here. So you see that you can use the chat. You can also comment and ask questions. Maybe that will be helpful for the jury members. Yeah, I think we will just start to introduce the jury, and we do it by the voice of the jury members. So I think I will start with you, Beata. Can you introduce you briefly?
Okay, hello everyone, good afternoon. I'm Beata Vereshova, and I'm from Czech Invest, from Czech Republic, and my main domain is startup development. So I'm really excited to see all these great ideas and explore the potential of all of them. So good luck for everybody, and back to the studio.
Thank you. Maris, can you introduce yourself briefly so that people get to know you as well?
Yes, I am Maris Alberts. I am head of the real-time system departments at the Institute of Mathematics and Computer Science, University of Latvia, but my main job is to be a farmer. I have a farm, 48 hectares large, so I spend all my free time. It is my hobby, not income yet, but therefore these topics here, these challenges are very interesting for me as a final user also.
Yeah, thank you. Glad to have you here, as well as Beata, of course. Now, Joanna.
Thank you very much, and good afternoon from my side as well, and congratulations to you all for being here today. It's very exciting for us as well. My name is Jovana Vlaškalin, and I'm working in Bioscience Institute based in Serbia. This hackathon is part of the Smart Agri Hubs open call. So I come from the Smart Agri Hubs project as well, where I work as a project manager, and my role there is to follow up on flagship innovation experiments in Central Europe and Northeast Europe, and I participated in many different open calls and hackathons as well, so I'm very excited to be here, and good luck to all.
Thank you, Joanna. Absolutely right to mention that Smart Agri Hub is one of the key organizers of this hackathon. And if you came in early, you saw that we have many co-organizers and supporters of the Inspire hackathons, and so we're very happy to have you here and all the other supporters. Joseph.
Hi, Hi, everybody. My name is Josef Hnoyel, and I'm from the Czech Republic. And I will be very short because I have been chief editor of GeoBusiness magazine. It's a local magazine for 12 years. So that's my job for last decade.
Yeah, happy to have you here. Yeah.
Thank you.
Thank you. Okay, so Hannah Kobikova has been, as you know, everybody knows her who has been involved in this Inspire Hackathon. We are trying to get her in here, but it seems to have some technical problems. Do not panic. I hope that the first speaker will be able to join us. I will, when the jury is consulting for the final scoring. So you see here very briefly that we are welcoming you, and then we start with the presentations of the results. We have, well, actually we have Christina first. So I don't know why Paolo, or was there a change? I'm not quite sure. Christina, and then Karol Jedlicka, Incoronata, or Rado Delina, Pavel, two Powells on the row. Then we have a break, and we have Akan, and we have Harman, Sarah, Righties, Antoine, and then we have a jury duty break, and finally a awards ceremony. So that's the plan. I think I will try to get Christina here, or I will see what the message is, if I have some messages here. I think I have Paola in here. Paolo, sorry. Paolo, are you here?
Yes, hello.
Yes.
Good morning to all. I am a member of the Liverpool project Horizon 2020, and like a member, like my pilot area in Italy, I am very happy to participate to the Hackathon COVID meeting. Really good work to all, and with a big pleasure to know you all.
Thank you. So, are you Paolo? Are you going to present?
My work is I am an agronomist, agriculture sciences doctor, and now I am in rest. I'm a consultant with my union of a municipality in a Trasimeno area in Umbria region. And my duty is to work for a living lab, rural living lab in center of Italy.
Okay, yeah. Thank you, Paolo. I think, thank you for joining. It was my mistake. I thought you were going to present, but you are one of the attendees. Very happy to see you here, Paolo. I will have to ask you to leave. This is like, this room here is like the stage. So we are inviting each of the presenters to join us on the stage, which means that we have to leave room for that person to arrive, which means, Paolo, that I will kindly ask you to leave the stage again. I will help you leave the stage again. So so that we can get, yes. Thank you, Paolo. Okay. So Christina, yes. Now we are recognizing the order. Christina is going to do the first presentation for us. She has two challenges, challenge number 2 and challenge number 1. So she is doing number 2 first. Yes. And Christina, I can see you are in here.
Yes, I'm here.
Yes.
I can't see myself, but maybe you see me.
I don't see your camera. So did you find the camera button?
I will try to.
or you can just
okay.
go
Yes,
on.
yes, yes.
Yes, yes. Nice to see you, Christina.
Good afternoon.
Yes, we need to see the persons behind all this work. Welcome, Christina. I think you know that we have a very short time for each of the presentations, so I invite you just to go ahead and start sharing your screen and present.
Sorry, I didn't hear the last sentence. So can I start this presentation?
Yes, indeed.
And you will push it somewhere, or should I?
It's easier for you if you can share your screen. You have then complete control.
Yes, yes, yes. Okay. So, just a moment. Mm-hmm.
Yes. While you are doing that, I want to say hello to some of the people here. Akanin is here. Pavel, Robert, Maria, Antoine, Powell, another Powell, and Mohammed. Yeah, so to those of you who are going to speak, make note of the order of the presentation and raise your hand so that I can invite you in. So when Christina is done, she will leave the stage, and then I will be able to invite you to enter the room when it's your turn. And we are seeing the screen of Christina. Just some adjustment.
Just a moment.
Yeah.
Sorry, just a minute. Okay, I'm here. Hopefully, yes, it's better now. No. Last thing. Okay.
Yes.
That's it. That's it. Okay, so good afternoon, everybody. My name is Christina, and my role here today is to briefly and shortly present you the first two challenges of this hackathon. For being more interesting, let's start with number 2, and then I will continue with challenge number 1. So this one has a title, Atlas of Regional Specialities, and my co-mentor in our tandem is Petr Horák. He is also here, but just listening, and I will present especially his work and his challenge. Maybe let's start, because here's also my colleague from Live project, Paolo. You already saw him. Some few words for this project. Live is an European Horizon 2020 project, and it is, or its name is focusing on living club concept and aims to support especially poor rural areas in European countries and Northern Africa. And it is designed for come up with innovative or extremely innovative business models for such rural areas and moving towards a circular economy. I speak about it because today in this hackathon presentation are also our partners from Pilot Action, also from Czech Republic, Úhlava, colleagues from Úhlava in Klatovy. And we are working together on their Pilot Action. And for this challenge, we choose this topic. And the primary aim was to push forward or push further the Pilot Action itself, because we have some difficulties there. And I have to say, and to be honest, to say that this challenge really was fruitful in the next discussion of the main problem of this Pilot Action. So we really grabbed the opportunity to push the Pilot Action further and to solve the main problems, to defining the main goals for this challenge, which was maybe the last few words, to develop an advanced and much more practical version of the Atlas of Regional Specialities and the marketplace or e-shop. and to think or to think out the proper way to intertwine it finally and successfully promote both, but especially the region itself. And the second goal was to support regional primary producers and primary food processors and making this info about them available for the final or end users or stakeholders. I will speak later about also other steps or other goals, but let's start with introduction because the time is away. So why this challenge? This hackathon is called COVID-19 Hackathon or Inspire Hackathon. So we dealt with problems related to pandemic and when it's changed people's shopping behavior. So, for example, there are some signs we use to increase potential for the online market. And also our product is about it. I will speak later about it. So the goals of the challenge itself was to eliminate the problem situation arising from pandemic by supporting regional primary producers and by collecting information about their products and especially making this information live and vivid and available for customers, as I said previously. And the last part of introduction, again, the main idea of the challenge to find solution, how to connect or intertwine regional information about farmers and their available products with various platforms for trading in these products. So this is our team. Our team consisted of 13 registered participants, 2 mentors, developers from Wireless Info, the public body Úhlavy already mentioned, and a concrete farmer, Tomáš Zelený, which also is on the platform, and you will see his own card intertwining on the catalog and eShop and Atlas of Regional Specialities. Maybe just one word about Wireless Info. We try to use some facts about us because Wireless was the first and the last, I think, living club in Czech Republic connected directly to ENOL, which is European Network of Living Club. And also from this position, we try to make some new solution or to bring new solution to the pilot action of Living Club project and to this challenge number 2. So the technical background. The best practices is a platform which will be here during this afternoon, introduced much more. Also in the challenges, I think 6, 8 and 12. And also in the second challenge, number 1, I will speak about it a little bit. Easily present interesting examples of practical implementation of the results of various areas of research and development. It was developed as a part of enabling project where it served as one of the main tools of the platform for sharing information of the alternative use of residual and waste biomass. The link is here available also for your usage. And it is also used or was used as a technical background of other challenges, as I said previously. The process of itself consists of several repeatedly available phases of brainstorming with our colleagues from Tandem Úhlava. Another type of development of the first prototype, continually adding their comments, recommendations, and further discussion of business model leading to implementation of comments, functionality improvements, and data updating, to the final discussion, validation, and other steps for the future. This is never-ending workforce, and we will hopefully and happily continue it with the pilot action of LIRUR project. So here are now, he followed 4 slides with results. This one, the technical output number 1, is a special project of the Atlas of Best Practices in this challenge, embodied in the form of Atlas of Regional Specialities. Also link you see here. And the project includes data about farms, but not only farms and their products, but also craftsmen, services with accommodation, etc. new ones will become and populate this database and this atlas. This is an example just for visualization for you to understand the main principles. This is the direct link, and for example, this is our main goal to effectively or efficiently connect these two parts or these two products, the atlas of regional specialties and the eShop itself, to be more productive, not only for the owners and the participants, but also, and that was the main idea for whole project, whole pilot action, and also for this challenge, to promote and to help to this, let's say, poor rural region where no special dominants are, but many small interesting places and, for example, farms are here, and people just want to know them in their surroundings. The promo is still not efficient, so this is an attempt to change it. Technical output number 2, it's the interconnection with the eShop regional specialty, when users can get from the Atlas of Regional Specialties, which is or plays the role as a info platform, and can get directly to the appropriate farm products. So the way is visualized for you. This is a point which will be or will have to be much more better developed. But we are now in the co-creation phase with our colleagues and working hard for enhance it. Another results connecting directly with the criteria of Hackathon, so ideas for further technical development. Another point like tools for local administration, redesign for mobile devices. This is the must, of course. And also we have to split map icons into groups, implementation of tourist destinations and attractions using smart points of interest. In the rank of ideas for modification of a business model. Yes?
Christina, can you be aware of the time, please?
Yes, okay. I skipped these hackathon criteria. I just wanted to prove that we mention them and we use it as a background, but I can skip it. Okay, so maybe the last one, innovation and sustainable criteria. Maybe the aim is to ensure the sustainability of the proposed solution, and if successful, to use this model. And this is really something very important for us, to replicable this business model or this model for also in other rural, similarly poor rural areas in other regions, not only in Czech Republic, of course. And the last one is I just read these two small texts. The solution of the Challenge 2 brings proposals on how to help local farmers and producers to place their products and services on the digital market and help consumers to find interesting products coming from their regions, directly from their regions. And to a prototype project of the Atlas of Regional Specialties made it possible to clarify some of the requirements of target consumers, primary producers, and the effect of local conditions. That's all. Thank you for your attention. And here is our contacts to both of us. Thank you.
Thank you. Thank you so much, Christina. My jury members, how are you? Do you have any questions for Christina at this point?
This is Jovana. So yes, maybe it was not explicitly clear to me, but can you please confirm the readiness level of the solution? Sorry.
I can't hear you now.
What is the readiness level?
Readiness level. Yes. I have to be honest to be honest, I must say that we have several telcos during these hackathons with our partner, and it was great. But some main issues has really changed for the last weeks. So we are now not in the finish yet, but we are aware of the main problems and we are solving them. And my partner or co-mentor, Petr Horák, is developing new steps in this platform, and he's mainly focusing these days on the intertwining of these platforms. I mean, the eShop itself and the criteria for it, and the atlas of regional specialties. So this is our main goal here, to solve the problem of intertwining it. So this is the current state of our product.
Okay. I think we can move on to the next presentation, Christina. And
yes.
Remember, 7 minutes.
7 minutes. Okay. I will be very brief. Just a moment. Sorry for this technical inconvenience, but I'm here already.
It's hard to calculate sometimes. So we go jump to the next one.
Sorry, Bente, do you see my first? No, not first slide.
You unshared. So
yes. Okay. So I try to again do it, and it's. Oh, okay. Mm-hmm.
So Elias and Paulo, I see that you have questions for Christina. I think we will refer to the document for those. Unfortunately, we have not time to discuss this much with the rest of you. We are focusing on the jury.
Vidíš to? Vidíš ten slide?
Ne, zatím ne. Může podívat.
So, do you see my first slide, please? Best practices catalog for eBay. Okay, super. So let me introduce the second challenge, number 1.
Máš strašný zpoždění.
Sorry. Okay, so I will speak about this catalog, which has maybe interesting title. It's Best Practices Catalog for eBay domains, which means eco, bio, agro, and geo domains for distant education. It's not designed only for teachers, but especially when I want to short it or be more brief, for any of us who wants to participate on trainings, self-education, which is in these days very important. So the problem was that there is a huge number or plenty of so similar self-standing catalogs of best practices and education materials, and which is very chaotic and confusing for the target group. So our solution was to come up with a simple application based on standards and offering not only isolated information, but really and vividly communicating with users. This is just a short or brief visualization of the development process itself. So we worked and created a data model, then populated the database, and then the cycle started, which will be continually cycle of data adding, data processing, user entering and changing, and another data populating. And we have a product now in comparison with the first challenge. We have a web form of catalog and also application for Android devices, which is our main product here. And it wasn't planned, but we did it. The results, the concrete results are listed here. So it's an eBay catalog in form of web page and application. Then the database of best practices, there are plenty of it. For example, education materials, applications, services, multimedia, data for eBay distance education. Open forum for it is also enables us with an open forum for adding new best practices. And also you can find there support materials like different webinars, but also in these domains, in these 4 domains, tutorials. And another important result corresponding with these above is experience, feedback, and new contacts. Another detailed information about results, but these were much more detailed described in our midterm and final report. But just let me to say that the data model is based on international standards and on controlled vocabularies. I have no time to be here longer, but this is the final or front page of our application. So with a simple click or one click, you get further to the menu, which is division of resources by alphabetic order, clusters, similarities, language, domain, date, for example, and also type of the document. Just see here that there are, for example, cluster with only unique material, for example, the best practices atlas. The reason is that it is so unique material that it stands only for one cluster, which you can imagine like a bookshelf in ordinary library. But there are also, of course, also clusters creating groups of similar materials, and you will see it on the next slide, where is the structure of the concrete card here, for example, Agrobusiness Times itself. So you find here name, the cluster, visualization of the similarity, and also very important info about metadata, which are information about the resource, and also very important recommendations leading you to links to similar resources. And you can very easily, or we hope, travel back or forward in the catalog itself. Future steps, there are several future ideas what to go or what to step further, adding new data. We would like to create a catalog of many, I don't know, hundreds of items classified here according to cluster or similarities. And also we put very big emphasis on community or networking and community body. And maybe at the end, because I have no time, so just to emphasize the benefits, all of them for us are very important because, for example, timing as the first one enables us with individual approach to education in this time in pandemic situation and hopefully also during post-pandemic situation. We started with this situation in the spring of this year as a condition, challenge, requirement. Then we decided to take it as an advantage and maybe and hopefully also as a benefit. The second one or type of benefit is domains and scope. EBAC is global topic corresponding with facing problems of society. And that's the reason why we choose these 4 domains, agro, bio, eco, and geo domain, because these domains especially combines the complex view or approach of 2 branches of science. If I speak about human sciences or nature sciences, they could both give their own response to global problems like poverty, hunger, climate change, etc. Interconnection is very important for us, of course, in the sense of content and data model. Again, a recommendation of similar resources and links to standards and vocabularies. And big challenge for us is a benefit of simplicity, because it should be very user-friendly, and user interfaces are very clear here and also smooth, as I hope, to be used by any people, regardless culture, their education, age, technologies, etc. And for the last but not least, our initial aim and main focus is on usage it in a business model, because agro-food business needs educated people and lifelong training. Why? Because educated people has some something like added value. They are able to, in complexity, view the problems I was speaking about, and this complexity is guaranteed by education. And our approach here in this challenge was to create such a tool for enabling them the vocational training, self-studies, etc., by very easy way. So I think that was all, and thank you for your attention.
Thank you, Christina. Thank you very much. We will allow, of course, questions from the jury. Do you need to clarify something from Christina on Challenge 1, jury?
Hello, Beata speaking. Good job. Just one question. It seems to me that this is something ready to shoot. Is it correct?
Yes, the product itself is ready. And for example, we have a link in our final report you can easily put into your mobile device, but it's not available yet in, for example, Google Play. It's not yet. We have some good reasons for that, but I have no time to explain it much more detail. But it's ready product. Yes, in comparison with the challenge number 2, here we really finalized something what we initially didn't aim to, but we create a concrete product here. Yes, application for mobile devices. Yes, and the goal of this challenge was also maybe to provide, I didn't say, experts, teachers, whatever, experts in agriculture, for example, this data and tool, which is this one, supporting distance education. So this is what's about it.
Thank you. Understand. No matter the form, I don't think it has to be like perfect. It has to be done, and I think it's done, and it's great. Okay, thank you.
It's very simple, but it's done. Yes, thank you.
Don't say it. It's done. That's
it's done. Yes, it's done.
Okay,
we were also very surprised. Yes.
Okay, thank you very much. In respect or in interest of time, I think we will. Yeah, can you unshare your screen? We will go ahead and move on.
Okay.
So, Christina, thank you so much. Impressive work, and you can enjoy the reports as well to figure out more. So, thank you. I will guide you out from the stage now, and I will invite Karol Jedlicka, who is the next one. Thank you. So, Karol Jedlicka is the next one. I just invited him, and if you have been following the chat, you see that this is challenge number 13, and we are going to hear about agroclimatic factors. And here Karol comes. I'm very happy each time we succeed in getting people onto the stage. Hello, Karol.
Hello, everybody.
Hi. Yes, we are ready to hear about the results from challenge number 13 and the agroclimatic factors.
Okay, so I'm starting to share my screen, and hopefully you can now see my presentation.
Yes.
Okay, thanks. So I will briefly introduce you the results of the agroclimatic factors as, let's say, piece of puzzle in regional food supplies forecasting. And I'm here on behalf of a big team, just one presenting, but you can see the people incorporating in this goal. First of all, I want to mention shortly the context, and it's the paradox of the agriculture in these days, which is on one side to acquiring higher and higher yields, but in the contrary, of course, to do some sustainable farming. These two issues go into contrary, of course, but we believe that if we use data and we gather some context from the data, we find some structure in the data, then we can do some objective reasoning about the place and plants or crops which will be will be grown there. So this is a very, let's say, general principle, but we believe that it can be applied to farming. And in particular, there are like 3 steps which a farmer needs to do when he takes care about his production, and its first decision is to select the right crop for a particular place. Then go to the field and intervene there only in the cases where it is really necessary, and when it's necessary, then do it in an effective way. So these activities and decisions can be supported by data. So it doesn't have to be only on the experience of the farmer, but he or she can also have some data from the data, the information, knowledge, and some reasoning. Then we hope that not the highest yield, but let's say a reasonable yield can be gathered while still the farming is done in a sustainable way. We actually, with the analysis of climatic data, the historical data, we believe that we can address the first 2 bullets. If we, which we are not for now, but if we get the access to forecast data, then we can bring a piece of puzzle to the third bullet point as well. And as far as we know, we are, of course, not the only one. We know at least about 2 other hackathons team which were working on this issue as well, and it's team number 3 and number 11, which we cooperate with during the hackathon. So our story, as I mentioned, we will work with comparing the place and the plant and the sustainability to each other. So first of all, let's and we hope that we address this particular topic of the hackathon, which is at the top, bottom right of the slide right now. First, the place. The place can be described by different physical measures, which can be then calculated into so-called agroclimatic factors, which means climate-related factors which have some influence to agro sector. So we can calculate the solar radiation, we can calculate water balance, we can deal with temperatures and get information about frost-free period of the place. We can calculate growing degree units, heat stress units if that's the case, and working with the, for example, soil temperatures, we can calculate some fertilization related factors. So these algorithms were developed and described. You can see the link to these algorithms. In fact, they were developed in advance of the hackathon. The hackathon was just about testing these algorithms, to be clear. So all of these factors are described, and I will now just do a very brief run through the results, because we already spent an hour webinar in the middle of the hackathon describing each particular chart here. But believe us that we were able to get to the data. Take like 40 years in the past. I will mention the data source later on. And then we were able to calculate frost-free period, growing degree units related factors, also the fertilization, etc. There is a solar radiation and water balance. Sorry about this very fast slideshow. And we discussed how it could be compared to a plant, and you can see that also the plant, no matter if it's crop or a wheat, but the plant can be described by some, let's say, growth stage models, but also with some model of growing degree units needed for the crop to grow. So it can be compared directly to one particular agroclimatic factors, etc. If we go for the other factors as well. This is still an issue to get the particular values for these models. This could be calculated. So this we have. This we are searching for. We have some preliminary results, but we need to get the access to right databases. But we have, so we then can compare these two information together and answer the question which crop is suitable for which place. Talking about the data, it's in the report. We discussed open data. We tackled with the uncertainty level of the data. And that's work to be done. We need to transfer the uncertainty from the initial measurements to the agroclimatic factors. In fact, we did some attempts on temperature. You can see the comparison of the climatic data, global data, with some particular meteorological station. Talking about technology, we used EUXDAT hub. This is basically cloud-based. There are some Python scripts which you can use, create these factors, and then there can be some graphical user interface connected. This is just for one factor. And I want to mention, because I'm running out of time slowly, the application which was also developed, and I will provide a link in a second. This is a visualization of the data calculated during the hackathon, so you can see the agroclimatic factors on the left side. You can go through time back and forth, so you can analyze the data. And we are actually working on some mock-ups which will provide also the graphs in some reasonable format and reasonable way to inform the ending user. We have now like one diploma and one bachelor thesis working on that, so it will continue. And I think that was my last slide. So you can again take a look at the application. You can find the link here, and I thank you for listening to our story of actually comparison of the suitability of a plant to a particular place. Yeah, that's all for me for now. So thank you, and I'm ready for questions.
Thank you very much, Carol. Jury, do you have any questions for Carol? No question. Everything is crystal clear. Beata.
Hello, Beata speaking. Impressive work, and I believe there's a huge amount of work behind the scenes. My question would be, how is this project sustainable for longer run? Because as far as I understand, this kind of project has a huge impact when they are run long term, and some kind of team is taking care of them. Do you see these aspects, or did you cover this aspect in your work?
Yes, it's actually the work presented was mainly from the project EUXDAT, and EUXDAT just ended last month, but we are continuing the development in the project Stargate, which will also help to keep the results of the EUXDAT project. Honestly, we are not ready for the market yet with this product, so this is why we need some more time to reach the market. And as I work at the university also, we have student working on that, and also projects which can support us like for next, let's say, at least 2 years to reach the market. And then hopefully the Plant for All Association could take care of the results if it's on a non-profit way, which is one way we consider this information, or there could be a spin-off if we see commercial potential, but I'm talking about 3 years plus now. So
okay, we cannot see the future, but it's good to know that the long run, at least for some years, is covered, and it's great. Okay, thank you.
Thank you.
Thank you. Any other questions? Yes. Any other questions from the audience? Oh, jury, sorry. No, I think we are good to go. Thank you so much, Carol. Can you unshare your screen? And I will excuse you from the stage and invite Rado as the next one. Thank you, Carol.
Thank you, bye.
So Rado will be the one who is presenting now the next challenge, number 12. And we are going to hear about the Atlas of Social Enterprises. And here Rado comes under a pseudonym, Hannah. So don't be, if you notice that, it's actually Rado. Rado, we see you are here.
Hi, hi.
Hi, can you turn on your camera as well? And there you are. Welcome, welcome.
Thank you.
This works fine. You can go straight ahead and tell us about the results from your challenge number 12.
Yeah, thank you so much. So I will share my screen. So our challenge was focused on working inclusion, especially to visualize social enterprises on the map. We are using Atlas of Best Practices tool to visualize social enterprises or social farm with basic information about the activity and with the main focus on potential for disabled to be employed. So it's quite simple application, but we believe that with higher social societal value. So that was the main objective, how to support working inclusion, because really disabled have problem with employment, especially in their region, because they have of course some logistical problems. So that's why we are thinking about using Atlas of Best Practices as a very useful tool to visualize not only working inclusion, but of course some additional information behind can be helpful then also for social enterprises, but we will explain it later. So now we are really talking about social enterprises where also social farms are in place, and on the one hand, they are trying to integrate disabled into working process, but on the other hand, of course, they are also offering some therapies for them. So it's multidimensional social value. So what was the basic idea? I will explain it in more detail on screen. So I will go back, yeah. So the main idea was to set up such a data structure which is quite short, quite concrete, or quite sufficient to be able to find suitable social enterprise in some location, in some region. So the main idea was to provide basic information about position of the social enterprises, basic information about basic functionality, how to filter this information according to some specific features or information. For example, you are seeing here that you are able to filter several attributes or parameters of social enterprise. So if you are looking for open position, job position, or disabled person is looking for open position, it can be filtered according to the type of disability or disorder. So if we would like to filter only social enterprises in my region suitable for hard motoric disabilities because I am on wheelchair or something like that, so I can filter and to be able to find if some social enterprise is offering this open position. Or of course we can filter according to country or directly this disability type. So the visualization here we are considering that it's very useful, not only as a standalone application here in Atlas, but of course we are thinking about integration of this data into third-party systems, for example into some job portals or other related information systems. I will say a little bit about it later. So then you of course have also some basic information about social enterprise. So if you are clicking on the social enterprise, you are able to see the basic information, address, contact, and especially some description about business activities. So we have this in local or also English language. So you are able to not only to understand what the business activities, what the main focus of the social enterprise, but also if there will be information about the production, you will be able to be integrated also, and that's also the objective or vision of this tool and project. It will be able also to be integrated into some public procurement environments, digital environments, where, for example, within national initiatives in social procurement, for example, in Slovakia, it's under law that some public procurers, public organization must have to purchase some volume of orders from social enterprises. So it can be helpful then also to these public procurers, but it will also generate some demand for production of the social enterprises. So here we have this basic information, not only about business activities, but also about the number of disabled employees. So how many employees are disabled in the social enterprise, and which type of disabilities are suitable for their job positions. Also, very important information about these open positions. Yeah, so that's the basic information, and we generate or collect some data. For example, from Slovakia, we were able to collect a sample of more than 200 social enterprises that are really registered social enterprises under the law of social economy here in Slovakia. So it's not some general enterprise with some social focus, but it's really registered. And this sample is whole. So in Slovakia, we have only 184 cases or social enterprises. These enterprises have real information about their business focus, about their address, contacts, and so on. But as we were not able to access the real information about position. We modeled the information. So the real information are only about this basic description about the social enterprises. So that's the case of Slovakia. We really expect that this tool or this idea can be really beneficial for Slovakia, and especially for Ministry of Social Affairs, because we are now discussing how to exploit this idea in our national social environment, and we are planning or going to really set up some bigger project to utilize this data and this form of visualization and this tool in wider context. I have also Incoronata here, my colleague from Italy who helped with data collection and preparation of all this challenge from Italy. First, I wanted to invite you to say some words about Italy, but I guess I am able to take the word. So from Italy, we were, or Incoronata was able to collect 40 Italian cases. It was focused mainly on social farms. So social enterprises within agricultural sector. There is also similar focus of the social farms. So on the one hand, they are able to integrate into work, into some jobs, this disabled community. On the other hand, they're also offering some therapies for this community. So it's the common perspective of usage also in Italy. So as I said, the design was visualized in this context, and next steps would be focused on enhancing some functionalities, because we need to have functionality for social enterprises to be able to update the information. Yes,
Rado, just a reminder that we are starting to go over time. So can you?
Okay, sorry. Okay, so
yes, thank you.
Only finalize. I said I guess the most crucial things. So the next steps are only focused on a little bit enhancing the functionalities for social enterprises to be able to update information. Okay, thank you very much. Also to be involved in this challenge, in this hackathon, because it's really very perspective also for Slovak environment. Thank you.
Okay, it was the last slide. I wasn't aware. Anyway, yeah. Thank you so much, Rado, for this presentation. Jury, do you have any questions for Rado and Incoronata? Yeah, Ivana.
Yes, maybe just to confirm, so you're based in two countries so far, Slovakia and Italy, so these are primary cases, right? But you're envisaging or planning to populate the rest of the Europe, but this is not a primer idea right now, but what is your focus is to be stable in maybe a few countries and then eventually spread, or how do you see it?
Yeah, sure. The first step is also to be able to test the pilot in the real environment in these two countries. Also with support of ministries, because they are also able to provide some financial support to be sustainable. But on the other hand, we will be also able to integrate it into these electronic public procurement systems, where we know that electronic or these public procurers are able to pay for such functionalities, because they are able then assess the social value of procurement. So I guess this service can be sustainable also on a commercial base. Yeah, you're right. We would like to stabilize the tool, the application, and to add some additional functionalities first in these two countries.
Okay, thank you.
Thank you very much. Thank you so much, Rado. I will kindly escort you down from the stage as well, and invite Powell to present the next one. Thank you so much, Rado.
Thank you.
So, yes, and I can invite now Powell, who will be the next one. And while we're waiting for him, I will like to thank you so much for the engagement in the chat. I see that there are several of you having a dialogue going on there. And this is correctly so. This is just in the spirit of the Inspire Hackathon format that we have this community created that interact with each other. So I encourage you to continue to ask questions, and those who are participating in the different challenges, go ahead and answer and engage in the chat as well. And welcome, Pavel.
Hello, Bente. Hello, jury, and hello, the audience. I hope you can hear and see me.
Absolutely.
I'm just going to share my screen. Okay. And the presentation is about Challenge 6, also about the Atlas of Best Practices. I think it makes it the third one in this hackathon. But our focus is on social innovations that were introduced in different regions across Europe to fight COVID-induced challenges in rural areas. And the idea for this challenge emerged from the experience of working on 2 EU projects, the Enabling Project and Polyrural Project, and some general awareness and understanding of the challenges that are affecting rural areas. So very briefly, because Enabling Project was introduced many times before today, our technical background using Challenge 6 is in fact the platform that was developed by the Enabling Project. And whereas they focused on biomass recycling, as I said, we focus on social innovations. And the platform itself is really a map with different markers. Once you click on them, you can then see additional information in the form of the snippet cards, where you have text, images, and videos. And recently, a Polyrural project adopted the Atlas for a different purpose, however. The idea here is to promote the experience of new entrants to agriculture, as well as rural newcomers who come to rural areas from cities to set up their businesses, not necessarily agro-businesses, but this can be some NGOs, charity work, community work, and other things. So these are the 2 factors. Now the third factor is some general awareness of the challenges that rural areas are facing, and here I just want to briefly mention some of them. We know from statistics that poverty and social exclusion is more prominent in rural areas than in cities, and although this gap narrowed in recent years, it is still quite evident. We know that rural areas have worse access to services, transportation services, healthcare services, broadband, internet. Only about 5% of farms in Europe are managed by young farmers, that is people younger than 35 years of age. And of course, for the profession in general and generational renewal in particular, this raises some concerns as more experienced and skilled workers leave the sector. And as young people migrate to cities in search of better opportunities to work, live, and study, opportunities to socialize in rural areas dwindle. And this can lead to all sorts of mental health problems, with isolation just being one of them. And to make a bad situation worse, we have specific pressures induced by COVID that affected many rural livelihoods, as restaurants, schools, bars, and businesses closed. Farmers and local agri-food businesses were no longer able to supply their produce to the stakeholders. many rural areas, as we know, they depend heavily on tourism, and particularly international tourism. But of course, this became very difficult during the pandemic with closed borders, etc. And the pandemic and all the lockdowns, of course, raised barriers in the form of logistical bottlenecks, and this affected the livelihoods of those people and businesses who produce perishable goods like fruits and vegetables. So these are just some of the issues that COVID added on top of the existing issues that rural areas were facing. And when we were trying to come up with the idea for this challenge, we thought, well, is there anything that we can do to help rural areas? And in particular, can we perhaps use the Atlas of Best Practice as an antenna for good practices used elsewhere, and which were proved to be effective elsewhere, to encourage new adopters in different regions to apply what was tried somewhere else? And we thought, yes, the answer is yes, so let's give it a try. And we assembled a team, myself and Peter, who was more involved in the technical aspects of the challenge. And then we, of course, had our participants. We received quite a lot of interest. Over 20 people registered, but when it actually came to real work, less than half contributed to the challenge, which was perhaps somewhat expected. And you can see here that we divided the audience into 3 groups: so consultants who advised on the look and feel, collectors who, as the name suggests, gathered the case studies, and testers who tested the app in the end. And our journey in this challenge included 5 steps. Of course, a welcome email where we asked people to assign themselves to different groups. Then we had the webinar, and the first alpha version of the Atlas with some dummy use cases was presented then, and we asked consultants to share some of the feedback with us. Then we proceeded with the collection of case studies. There were 4 people interested in that, so we engaged them and asked them to search for information, ideally from their region, which we could then later share through the Atlas. And the idea was not really so much to recycle what's published already somewhere in the news, for example, but to really find local use cases that aren't that visible. And the intention was to make them really more visible through the Atlas. The last step was integration and testing that happened a few weeks ago. And here you can see basically the results that we achieved in the end. The template on the left is what we used as a tool to collect information. So some of the things we were interested in, for example, is who designed the innovation. And we deliberately kept this field broad because we didn't want to limit it to just public authorities or businesses. You know, we made it really open, and we're accepting use cases that were initiated by individuals, charities, NGOs. We also wanted to know what were the results, quantitative results in particular, let's say how many people benefited or households benefit from it, and whether the innovation is replicable. In other words, can other regions easily adopt this practice in their own place. Because we only had 4, we published 4 case studies. 2 of them are from Finland, 2 from Spain. Very briefly, I'm just going to say a few words about each one of these use cases. So this one from Kantehame was the innovation was initiated by an NGO there, and the idea was to raise awareness about local food production by increasing the visibility of local farms and companies, and that was done to make it a bit easier for both locals and tourists, maybe not necessarily tourists coming from abroad, but tourists coming from within the country to find this local services. Another case study from Finland was really community-driven, and there the idea is to support tribal products. Like here on the picture, you see a hoodie, but they also have all sorts of craft products there. And these products are produced in a village house, which also acts as a community center for local people where they mingle, socialize, and it really helps bring people together and increase and improve their sense of belonging, solidarity with the region, which I heard was badly affected by COVID, and people in that place, they like to wear these hoodies and use other devices, wearable stuff, to show the solidarity with their local folk. Then this Spanish case, also quite interesting. It was initiated by a private association, and they wanted to repurpose accommodation in that city in order to accommodate newcomers that arrived during the pandemic. And some traditional office space was then transformed into a digital co-working space where some training activities happened and new arrivals were accommodated. The fourth and the last use case that we collected kind of covers the whole of the country, and it's a recent initiative by the Spanish government to make rural areas more attractive in the wake of the pandemic. And here they list 3 bullets through which they try to achieve this goal: improving water and energy efficiency, boosting competitiveness and sustainability of agriculture through things like precision farming, and improving digital infrastructure, broadband and internet in rural areas. And we obviously intend to expand the collection, and Polyrural project is still ongoing, has 1.5 years more to go, and we will be collecting some more case studies as part of Polyrural, and we hope that this atlas and the collection that we publish there will serve as an inspiration for the different stakeholders in different regions. And by reading these case studies, we hope that local farmers will be supported. People will be encouraged maybe to buy more food from them because they were badly affected. Stakeholders, the new regions, will perhaps know the different ways in which they can integrate new arrivals. And now I'm referring, of course, to that Spanish case study, promoting local tourism, also known as staycation, and perhaps some businesses will feel encouraged to change their business practices once they read the best practices that we collect for them and publish on the Atlas. So that's my presentation very briefly about the Atlas, and I don't know if you have any questions for me.
Yeah, thank you very much, Pavel. Yes, the jury, do you have any questions for Pavel? Yeah, Maris.
Yes, yeah. Is it possible to receive some prototype of your system to organize a trial in some rural community?
Yes, we have a link. I don't know if by prototype you mean some source code or just a link to the platform itself. Because I heard that you are from Latvia, and we would be happy to receive maybe some interesting examples of how farmers in Latvia implemented strategies to improve their resilience in the face of COVID challenges. So that's something certainly that we can look into. I will paste the link now in the chat, and you can take a look at.
Okay.
Yeah.
At the platform.
Okay. That's a definite sign of interest, Pavel. So the results and relevance. So thank you very much. In the interest of time, you can unshare your screen, Pavel, and I will escort you off the stage and invite yet another Pavel. Let's see. We are going to be presented challenge number 3 on citizen science perspective. I see again very much activity in the chat. This is awesome. We really appreciate that. And while we are waiting, well, here Pavel is coming. Pavel, can you turn on your camera as well? We hear you.
Yeah, great.
Hi.
Hi. Hello, everybody. So shall I start? Or?
Absolutely. Go ahead.
Yeah. So I start sharing the screen, and there we go. And once more, I just make this works. Okay. So I press play button on my clocks. So greetings, everybody. My name is Pavel Hayek, and I will be speaking on behalf of the team, the core team of the challenge number 3. And let's dive into the challenge of ours. We had 3 main goals. The ultimate one was the spreading the idea of map data sharing among people using so-called map compositions. You can imagine the map composition as a mashup of cartographically symbolized data layers in a few words. But first of all, we need some data to share. So we had to collect some relevant data to the hackathon and to other challenges coming from that we were cooperating with. So along the way, we of course improved some components and tools of the workflow which we used for map data publishing and sharing. The workflow is depicted on this slide on the right side of the slide. Basically, we used only open source components and tools in order to be able to share the data using the OGC standards. On one side, we can take a thick client of Quantum GIS, the representative of geographical information system based on desktop on one side, and on the other side we used HS Layers NG, which is a web-based tool for data sharing. And we tested heavily this workflow of sharing data from your personal project in Quantum GIS into the HS Layers NG and sharing the data through the internet. This is the example how the plugin for the QGIS looks like. The plugin itself is called the QGIS Layman plugin. The Layman is abbreviation for the layer manager, so it stands for managing the layers within the project of Quantum GIS. You can do whatever you want within your project, and then you upload the data to Digital Innovation Hub. And thanks to the workflow on the other side, there is this web-based client of HS Layers, which takes the data you uploaded on a hub, and either you log in to see your map compositions, so the mashups of the data layers shared or uploaded to the server. You can choose from your own, or thanks to the Mitska metadata catalog, you can share or see the map compositions of others. Thanks to that, you can create also more mashups, more map compositions, because you are able to create the data compositions using the HS Layers client as well. And then you can share it, what you've done, through the permalink or social media posts. So these were 2 most crucial parts of the workflow which was used during our challenge. And while we are related to COVID-19 Inspire Hackathon, we try to find some related or COVID-19 related data. On the left upper side of the slide, you can see data related to COVID-19 worldwide from the 1st of September 2020 about the cases and deaths at the particular time, and the cumulative ones as well. These data are downloaded from World Health Organization. On the lower right side of the slide, you can see the map compositions of the same data, but for the Czech Republic, obtained by the Ministry of Health of the Czech Republic. While on the bottom side, you can see the maps in Quantum GIS desktop client, and the map, which is in red scale, you can see visualized through the HS layers client above the 3 maps below. Thanks to that, we were able to have records of the data on a 2-weekly basis, so we can compare the situation or how it has evolved through the time. But we didn't take just our data or the data we obtained. We also cooperated with other challenges, and from some of them we successfully obtained data which we were able to share through the workflow which I presented earlier. Here you can see on the left side the frost dates maps, let's call them maps, for the Pilsen region in the Czech Republic, which were produced in challenge number 13. You have already seen such data in Karl's presentation. And on the right side, for the same area, there are data of the first fall suitable date for fertilization for a particular year in last 30 years. Another example is related to challenge number 4, the rural attractiveness, where you can see the map composition visualized via the web browser regarding the attractiveness of the continent of Africa in several point of views. And I'm getting to the end of my presentation. Here you can see the challenges we were cooperating with, not only on the base of data sharing, but also in the base of developing some tools or giving some mentorship as well. And to sum up what has been done in our challenge, I would like to say that thanks to the effort of the challenge participants, we started a process of sharing map data. We made a huge progress in validation of the workflow components and tools, and we managed applying our map sharing workflow to different fields of interest. Not only the COVID related, but also the agriculture related and other stuff. So the tool presented within our challenge can help anybody share map data or map related data, create deeper understanding of data, and it can be used for building your own application on top of the presented solution, both for commercial and non-profit purposes, because the workflow and the components of workflow are freely available and they are open source based components. The only thing which is mandatory is some kind of registration yourself to have the access for a particular hub. So this is all from me for now, and I'm happy to reply any question you have. Thank you
so much. Thank you so much, Pavel. Okay, jury members, do you have a question or two for Pavel? Yeah, here, Maris. Yes.
I have a question. Let's suppose I'd like to build my own application. what are requirements for the knowledge of the IT specialist or programmer that they can do it, what they need to know, which programming languages, and if I do not know anything about your platform, then how much time it takes to learn it?
Well, thank you for the question. To be honest, I'm not really sure because I'm not the developer of any part of the workflow. But I believe there are some guys from my team which are able to answer your question. But from my point of view, any knowledge related to GIS tools is just a background for doing such thing. So the programming language, I believe it's open, how it's called? Open layers, yeah. For the HS layers, it's open layers platform, and for the plugin, I believe it's built in Python, but I'm not really sure.
Okay, it means that somebody has worked with Quantum GIS, and this programmer has done something, some application. Then it means that in a very short time, he is able to work in your environment.
Yes, exactly. Thanks to the development and thanks to the time we had within the challenge number 3, we were able to make the workflow smooth for people which are not that familiar with GIS in general. So we believe it's quite straightforward, but of course, some people might have struggles and some people might find it very easy to use it.
Thank you.
My pleasure.
Thank you very much. Yes, can you unshare your screen also, Philo? And thank you so much. And before we are now allowed to take a break, and before we take a break, we would like to try to invite Hannah again. So Hannah, can you raise your hand? See if we are more successful. We were successful with her link. While we are waiting for Hannah, I would like to agree with Karol Jedlicka, who is observing that all of these, so far, all of these challenges have been based on results from other projects, and it's exactly in the spirit of the Inspire Hackathon. So I learned from Hannah now that she has trouble getting in. It's nothing with the link. I think then, Hannah, you need to look at your computer and see if you have approved and accepted all the software that is necessary, because your link worked with Rado. So I would like to invite you to do that. Meanwhile, we will have now a break. In this break, you will see a video telling a story about the COVID-19. We will meet here again in 5 minutes. So 14:09, according to my watch now. We are a few minutes behind, not too bad, all things considered. So please join us 14:09, and enjoy the video of COVID-19, and take a break and breathe and do some exercises and get ready for the next session. So I will invite Akanin to see if he can enter, and I will start the video there. Yes, hello. Welcome back. I am now looking for the next speaker, which will be Jirka, not Akanin, that I first thought. It would be Jiri. Jiri Krapil, can you please raise your hand so that we can invite you into the room? So we get started with challenge number 7, which is about blockchain. Very exciting. Let me see. Yuri, here you are. Thank you, Yuri, and you will be shortly in here. Jury members, are you ready?
Ready, of course.
Yes. Good. Let me see here. So I don't know, while we are waiting for Jiri to join us, I just want to point to the sticky information here, where you can find, where I have posted a link to more information, all the information about the COVID-19 Inspire Hackathon, including description of the challenges, who's in there, and the webinars. And Jiri, I think you are with us now.
Yes, good afternoon. Can you hear me?
We can hear you, but we cannot see you.
Well, that's fine because I didn't turn on my camera yet, so it goes on now. Can you see me as well?
Yes, Jiri.
Hello, good afternoon. So, thank you for this opportunity to speak. Originally, it was agreed that Akan will say the part on the social economics, and I will follow up with technical part, but he had some technical problems, so I will take over the whole presentation.
Great. Thank you for that.
So now how do I share my screen? Sorry for that.
The button is...
I see. Okay. Enable. Wow. Looks like this. Sorry for that. Oh my God. I don't see the right... Oh, the whole screen. Okay. You know, there are so many security restrictions now in these modern browsers. What does it want now? I want the whole screen. Firefox cannot grant access to your screen. Brr. Okay. So it looks like I'm not able to share my screen from Firefox.
No, okay, you are using Firefox. Yeah, understandable. You don't have a Chrome browser?
Yes, I do, but sorry, it's my fault. So do I need to switch to Chrome?
Yes.
So maybe I think just to save time, you just take some other presentation and I just meanwhile fixed things. What do you think?
Yeah, let me see if I have the next speaker is ready to go on. That's Herman. Herman, are you ready to join us? Challenge number 11. So Herman, I don't know if he was calculated. It's very close. Herman is there. Yeah. So Jiri, I will escort you out of this.
Yes. Thank you. And sorry.
And I invite Herman. So here we go again. So now, Jiri, we take note that we are now going to learn about challenge number 11. Challenge number 11, which is about Earth observation for monitoring of regional food supplies deviations.
Hello, Bente.
Yeah, hi, Herman. Welcome. Thank you for showing up on short notice. The floor is yours. Go ahead and start the presentation.
Okay. Yes, I will share it. Good. Yeah, our challenge was about monitoring of regional food supplies, deviations, and I will show you the work of our team, what has been done in the last few weeks. Our team was in our team we interconnected the knowledge of experts with the innovation of the creative members, and there were several people in our teams, and yes, the starting point was these yield potential maps, and our aim was to make use of them and help the farmers with the yield predictions. In the picture, you see an example of a yield potential map in a South Moravian farm called Rostenice. In simple words, it shows how well the crop grew in the past. It is calculated from enhanced vegetation index, and it is averaged for 8 years. So this was an input, and now I will show what we have done in our experiment. In the left image, you see one of the interesting outputs, the mean of enhanced vegetation index for the whole season. It has similar meaning as the yield potential you saw on the previous slide, but this is for the specific season. You see which fields were above the mean and which were under it. It is very easy comparing method, but it's quite inaccurate comparing, because the mean is affected when there are no data in some days when it is cloudy, for example. So we thought how to provide the farmers with some easy and correct comparing method, which would tell them which fields are better than the others. And we thought out an integral comparing method, which you see bottom on the right. In this method, each pixel is assigned with a value which equals the integral for the whole season. An integral is a number represented by the area under the graph, under the curve. Unfortunately, we did not have enough time to apply this theoretical method on real data. On the right top corner, you see a graph showing the temporal development of EVI. And during the hackathon, we focused on winter wheat, and other crops were done just for comparison. And as you see, the highest values of EVI were achieved in the end of April, and in the beginning of May, the values start to decrease slowly. Yeah, that means that in the April the crop is growing fast, and then it's not growing because EVI is not increasing. While analyzing the satellite data, we faced a serious problem with the cloud cover. We have chosen to analyze season 2018 because it was very dry season, so clear sky more often than in other years. We were able to use 19 satellite images from late March to the beginning of July. Not all of them are completely cloud-free, but most of the fields were without clouds. In average, it was one image each 6 days. So sometimes in some months there were more images, and in some months there were fewer. It's not bad, but it is less than half of images in the period were suitable. So in other years or other season, the portion of the unsuitable images is larger. Because enough of data is essential in our idea of monitoring development of crops during a season, we decided to try to use Sentinel-1 images to fill in the gaps in Sentinel-2 image series. The advantage of Sentinel-1 is that it uses the radar signal, which is not affected by clouds and doesn't need light to get the data. On the other hand, the disadvantage is that the processing and interpretation of the data from radar is more difficult and less documented. In the map on the left, you see the mean values for ratio vegetation index for Sentinel-1. We can compare this map to the mean values of enhanced vegetation index on the previous slide. However, to be able to use this index from Sentinel-1 in EVI series, more research has to be done and some mathematical formula has to be derived, because number 1 in this RVI doesn't mean number 1 in EVI. And on the right, you see the comparison of the indices. You see that the trend of the curve is similar, but it's not 100% the same. And here we get the most interesting and promises outputs of our work, and those are difference layers. The difference layers are calculated from enhanced vegetation index rasters by subtracting 2 consecutive dates and dividing it by the number of the days between the dates. This value shows how quickly the enhanced vegetation index changes, both positively or negatively. The difference layers from the beginning of the growing season is shown on the left image. In the legend, you see the data are calculated between the 11th and the 3rd of April. And you see that EVI is increasing. That means the biomass is increasing, or in simple words, that the crop is growing. And on the other side, when you compare EVI layers in the beginning of May, you see that the values start to decrease. Not a lot, but still the peak is already over. The use of these maps could be when evaluating impacts of some meteorological phenomena like drought or flood. It is simply a more detailed look on what happens on the field during the season. We tried to find some example of use of this method in the literature, but we did not find anyone to use it before. And this is a final result, this web application where anybody can look at the data. I'll try to show you how does it look.
Herman, can you also do that quickly in interest of time?
Yes, definitely. It's last slide. And here in Layer Manager, you can do that you want to see the difference of the indices, and you see the data by using this time controller. And this means that you see the difference between the date you see here and the previous date. And by this way, you can see how the vegetation grow in the beginning of the season. And yeah, anybody can look at this map using the this link. So it's all from me, and thank you for your attention.
Thank you so much. Thank you so much, Herman. And do we have any questions, some quick questions from the jury to this challenge? Yeah, Joanna, you're muted.
Okay, better now. Yes, so can you please just explain us or just make a connection to COVID-19 situation? Because we saw a presentation on the system, right? But how do you connect with the pandemics?
Yeah. This connectivity was described mainly in the the final report, the reports, but it is our solution should help the farmers, or mainly the farmers, to be able to predict what will be the yield, and because in this situation when there is much more pressure on some logistic, or even for the farmers to be enough of food for everybody, and when a farmer knows that there will be, I don't know, much less of some crop, the government of some authorities can do some can make some decisions which will lead to be enough of the food for the people when there will be less food on one place. They can they can just buy some food from another place where it is enough of it.
So, monitoring for better management of potentially limited resources, food resources. Yeah. Thank you very much, Herman. Thank you very much. I will excuse you from the stage, and I will invite then Jiri again, and see if we can be having him sharing his presentation. Let's see if I have any more questions here. Yeah, so just a reminder that when we are approaching the end here, you will be getting a poll so that you can choose your favorite and most interesting challenge. But so wait for that. It will be ready soon. Okay, Jiri, I see you are in here.
Hello, good afternoon again. So attempt number 2, and I will start to share my screen.
Yes.
Okay.
Does it look better?
Yes, but I still don't see the PowerPoint, the option to share the PowerPoint window.
There are applications you should probably see under applications.
Yes, I see applications. I see Skype, everything except PowerPoint.
Then there are two. I think there are 2 folders. Maybe click on the second folder and see if it appears there.
Yes, now I see it.
Good.
So can you see it?
Yes, we can.
What I'm doing here? No.
It's not in the present. There you go.
And now it should be in the full screen.
Yes.
Okay. Sorry for for a complication. So, challenge number 7. What was the target or the main objective of the challenge? It was application of blockchain technology for food security in Africa. It was just to start with blockchain technology because it's something like Yeti. Everybody is talking about it, and not so many people have already tried it. So we just started quite ambitious thing to work with blockchain. So we just started from scratch. No one of us had any any experience and really out of blue. So we just need to first map the requirements in Africa. So African colleagues in Hackathon, they just provide very valuable inputs. And so we know that the African food chain is made of smallhold farmers, and they are struggling with a food supply chain which is heavily fragmented and coupled with non-transparent, inefficient, and non-communicating business networks, which is getting even worse now in COVID-19 situation. So this is very vivid topic, and it's even more shining. All the processes and networks are quite exploitative to the farmers, so they are not being paid as they deserve. There's lack of transparency and accountability, and, which complicates the fair pricing and quality of products. And the goal of the challenge was to gather information about African farmers, what are the challenges, and mainly to develop a blockchain technology and to demonstrate that it's really viable and we can use it. So we didn't have any big ideas or big goals to develop everything within this one small challenge within a hackathon, but just wanted to start with something really working. So we just gathered information from colleagues from Nigeria, Cameroon, Zambia, Uganda, Kenya, and other African countries, which we used as an input for and development of blockchain technologies. The biggest challenges are illiteracy, and then you can see technology. We can help with technology, but not with illiteracy. This is something which needs to be solved by local authorities and governments, but the rest or most of the rest can be solved, or at least could be helped a lot by blockchain technology. The issue is that, or the goal is that we need to store data and information that various actors can get in, and we assure that the food supply chain is good for assuring fair conditions for farmers and everyone, that we have a good food traceability, food safety, and good food quality. And now to the technical part. So as I've already mentioned, we have just started out of blue, nothing, no real experience with blockchain. So first we had to make some research of information and what a blockchain is and how it really works. So all of us sort of have some feeling, but it's always good to have own experience just to get hands dirty with something practical action. So the main blockchain concepts are all transactions have their own hashes. Hashes, something like unique ID. So whatever you, any operation you commit within blockchain, you get a unique ID. All history of transaction cannot be changed. So it means that every new transaction is or contains checksum of previous transactions. So you can imagine that you have a list of a transaction, and once you reach the end of the list, you just make a hash of the whole page, and then if you just finalize all the pages, then you just make a hash of the book, because you are just counting with hashes of bigger and bigger blocks, because you cannot, of course, when the database or the blockchain is growing, then you cannot make a checksum of all small transactions. So it's like you are just building blocks, building bigger and bigger chains or bigger blocks which you are using to calculating hashes. And all transactions, of course, are traceable, so you can in any time you can know information about history of any operation. There are many blockchain technologies available, so I've spent a lot of hours by research on the internet, just testing and trying to install something, and the criteria was that we need availability of at least command line interface, because most of the technologies, so blockchain technologies, are really in rapid development, so they are just offering programmer APIs which we wouldn't manage to work on because we just had a limited time. So we need something with at least command line interface, or ideally with web interface, which wasn't the case, but finally we managed to get command line interface at least. And yeah, of course, problems are with Documentation, as all the software is rapidly developing, so no programmers like to write documentation. So new versions far ahead of documentation, and it also needs a friendly installation because most of installation is requires source code compilation, and there are some issues. So all of this we need to take into account to assure the good result of the hackathon, of our challenge. So the winner was, after some trials and attempts as well, the winner was Hyperledger Aurora. It's simple, it allows for rapid deployment because it's available also as a Docker image. So we just run a Docker image, it was working. It offers a command line interface. You can see below in the box how it looks like. If you remember, software 20, 25, 30 or more years ago, it's something you are very familiar with, and it has updated documentation, well, sort of, but it was fine when compared to some other technologies. And we just wanted to map a very simple. He is working in a wholesale, and the wholesale is selling the products or reselling the products to consumer, which is represented by shop. So this is the visualization of transactions. We just started free test users. In the blockchain, there was a farmer, there was a distributor, and there was a consumer. As you can see on the left, each was given some initial amount of products, which we just named the product, generic product. It can be wheat, potatoes, whatever. So we just used products, and we were just simulating transaction of these products within this chain. So farmer was selling products to distributor, and the distributor was selling the products to consumer, and it was working. Now I would like to show you the real example how it looks like in a blockchain. So remember, it has a very simple command line interface, which is sufficient. So we are starting that we want a new query. So we just select number 2, new query. Then we just want to know the account assets. So we just want to first see the amount of product at the user farmer. So you can see the farmer is an account we are asking for amount of asset, and asset is product. And here we can have it. We have it printed. So farmer has 500 of products. So the balance is 500. So it's okay. So we can start with our first transaction. So here we start that we can start with a transaction. So we choose transfer assets number 4, and we here search account farmer, destination account distributor, asset. So what kind of product we are transferring? Its product, and amount 100. So now we have made our first transaction in blockchain. We have moved 100 of products from farmer to distributor. And you can see the system has replied, congratulations, transaction was accepted for processing. And the most important, this is a building block here down on the bottom of the screen, is the hash. This is the unique hash of the transaction. We will use it in curious later, but this is what blockchain is built on, these hashes. So now we can ask about the status of this transaction we have previously made. So here we put a hash we have received from the previous transaction, and we are just asking for the status of transaction, and we can see the transaction was successfully committed. So it means that it was transferred. So we just managed, if I go one back, so we just managed to transfer 100 of products from farmer to distributor. Here the confirmation it tells us that just we have used source and destination account and products, and which are in the system, that we have no erroneous input, but doesn't tell us anything about the result of the transaction. For the result, we can see it here. In case we would try to transfer more products than the source account has, then you would see here that the transaction was rejected, because you cannot transfer more products than it was rejected. It's not written here. I don't have slide for this, but it's in our report, where all of this information you can have a look. I have written it as a manual, so you can follow it and you can reproduce what we have done. And here what happens if we just request the transaction log history about the hash. This is again the hash from the transaction we have made. So moving 100 products from farmer to distributor. So we just put this long hash to the system and ask for it. So here we can again the reply is hash again. Creator is a farmer. Time when it was created, it's the Unix time. It's a number of seconds since the year 1970. Number of commands, there was just one command, and we were doing transferring assets. It was from a source account farmer to destination account distributor. Asset was product, and amount was 100. And that's all. It's there in the blockchain forever. And anyone who has the right to access blockchain, at least for reading, can see this and check this. And there can be some public control that the assets, which in this case are products, but can be any agriculture product or whatever, or even this cryptocurrencies. But now we are dealing with agriculture products. Everyone can see the history and can check. There can be some public control of the food supply chain. So the conclusions are that blockchain has really proven as usable and suitable. We have managed to get the back end of the system running. It's ready, and the next step would be to develop some web interface on top of this backend, because this is just for demonstration to use it on a command line interface. To have it in real time use, you would need at least a web interface, or ideally some mobile application, and it has a huge potential for future projects. So I would like to thank you for your attention.
Thank you so much, Jiri. This was very interesting, as the rest of the presentations here, of course. Let me hear if we have some questions from the jury.
Do you produce product traceability passport?
Well, this was the very first encounter with the system, but of course it's possible. It's just application on top of the blockchain. We're just using the very much the background of the system, but this is just user application on top of blockchain. So you can take a blockchain as a database, and you can curate and get information you want, and get any own query you want. So yes, it's possible.
Yes. And second question, which hash function you are using?
I would need to have a look in the system. It's done by the system. I would need to check, but they are using some own checksum function, which is developed by this hyperledger Aroha. They were just keen on this function, so I would need to have a look. It's not anything widely available. It's being developed by Aroha. It's their own hashing mechanism.
Yeah, I calculated it is 256 bits long. Okay, thank you.
Welcome.
Thank you. Very interesting combination. Okay, let's see if we can move on. We are a little bit behind the program, so I think I will excuse Jiri, and I will then invite Sarah, who will be talking about, what was it again? Rural attractiveness and visualization of that. And Sarah, you are on your way in. I have been asked to share the presentation, so let's see how that works while we are waiting for Sarah to join. Yeah, here she comes. Sarah, we hear you, but can you turn on your camera as well?
Yes, just a second. Here.
Hey, Sarah. Okay, we succeeded in getting you in here. I don't know why you want me to share the presentation, but I can certainly do that.
Yeah, it's because on my iPad, and
right.
Navigating everything here is a bit difficult.
Sure.
To make sure
Yeah.
it runs smoothly. Yeah.
Okay, let's see how we can do this. I think I got it. You probably see it, right?
Yes, now I'm seeing it. Yeah.
Yeah, and I will do it in a full screen. I won't see anything, so I will just follow your leads now. Okay?
Okay.
Go ahead.
Okay. Good. Yeah, so again, hello everybody. My name is Sarah, and I'm one of the mentors of challenge number 4, visualization of rural attractiveness. And we can go to the next slide, which is about the background for our challenge. So many rural regions have for quite some time suffered or faced a rural exodus. So people were leaving or are leaving rural spaces to live in cities. And Pavel has described in his presentation on Challenge 6 very nicely the consequences this brings with it. But now COVID-19 has changed some things. So nowadays, many people work more at their homes and rarely go to the working places in the city, and also activities that people used to do in the city, they're not that available anymore. So living in the city doesn't really have that many advantages anymore. But the disadvantages of living in the city, they continue. First and foremost, the high costs of living in a city. So there are more and more people who really consider moving away to a more distant place, to more rural places. And it's not just people, it's also companies to think that way. So COVID-19 has brought a crisis upon us, but it also offers here a chance for rural regions to reverse this trend of rural exodus. That means that they are more able now than ever to keep the people who live there and to attract newcomers. But of course, people and also businesses will be more inclined to move to a place that they find attractive. And so the rural decision makers, planners, and other stakeholders, they will want to evaluate and find out what they can do to keep or improve the attractiveness of their region to attract more newcomers and keep their people there. So to support them in this task, we developed a web application that visualizes rural attractiveness across Europe. And this has happened already before the hackathon. The application already existed. And the main goal of our challenge was to improve this application. So we wanted more data, we wanted to make it more useful and more user-friendly. So next slide, please. And yeah, why did we actually think that this would be of any help to anybody being faced with the task of evaluating rural attractiveness? So first of all, visualizing data makes it more easily interpretable, which is especially important if it's to be used by, let's say, normal people who are not experts in processing a high amount of data. And a high amount of data is exactly what you get when you try to evaluate rural attractiveness, because you have to consider many different aspects here. So by visualizing it, you can integrate all of these different data on the different aspects into one single information. And by turning it into a visual signal, like a color, it gets much more intuitive to be interpreted. Like this is what you see in the upper picture with the green and red shades. Like with a single view on the map here, you can see where the more attractive regions are, the green ones, and the less attractive regions, the red ones. And yeah, this is one feature of our application. And it also offers another feature where it shows regions that are, so groups of regions that are similar to each other in their rural attractiveness. And this allows regions to find cooperation partners, to work together on their common challenges and needs to find solutions. And it also helps to set up more efficient support systems, also the financial ones, because they're better targeted at specific types of regions. Okay, so this is the advantage of visualizing the data, but why should we also put it in an online web application? Of course, this allows it to be accessed by a higher number of people if it's online, and then it also offers more functionalities, like people can better contextualize the information, they can zoom in, view specific region, but they can also zoom out and view the bigger picture and compare across whole Europe. And also our application also allows the manipulation of the maps here. So people can change, or they can adapt the maps according to their preferences. And so the outputs that they will get from the application, they really fit what they want to see. And all of this is, of course, not possible if you just have a static map. So next slide, please. And yeah, in order to work on our application and to improve it, we set up 3 working groups in our challenge. So we had one group of web development and data visualization. These were the people who mainly worked on what you actually see in the application, the way the map is displayed, the functionalities that the application offers, and the way everything is organized. We had the data experts, who are the people that worked on everything that is behind the application. So on getting more data and getting better data, on improving the ways the clusters and the rural attractiveness index is calculated. And we had a third group of rural affairs, which were less technically inclined people, but who were people who are actual stakeholders of rural development and rural affairs in different regions across Europe. So they offered very important knowledge and feedback on what this kind of users, which we're actually targeting with the application, what they want, what they need, and how they can handle such an application. And next slide, please. So what we got as results of our work in the challenge is, of course, the web application, which is also part of the Digital Innovation Hub of the project Polyrural, for which it was actually developed at the outset. We have a very comprehensive data set, which is behind the application. We implemented geo-reports of NUTS3 regions, so like regions on a quite low level. This means if you click on a region in the map, you will have a pop-up window which will give you more detailed information on this region. We improved the clustering method, so clusters make more sense, the clusters of the similar regions. We had the people from the Rural Affairs group test the application thoroughly. For this purpose, we had some testing scenarios, and with that, we got some feedback on how well this works for them, what already works well, what doesn't work so well, what else they would expect from the application, and so on. And we also developed some educational materials. This is for the webinar during the hackathon, but we also created a video tutorial on how to use the web application. So next slide, please. And this is what the web application actually looks like. It's very similar to the other applications that we have already seen. And in fact, we have at the moment 2 applications. We have one that displays the rural attractiveness index. So this is the thing with the green and red shades. And we have this one which displays the clusters of similar regions. And for the hackathon, we focused on the cluster application. And also here in this application, we have this layer manager where you can manipulate what you see. So it's now possible to select the number of clusters that you want the application to calculate. You can define the preferences, what is important for you to know in calculating the cluster. So maybe you think the economic aspects are not that important for what you want to know about rural attractiveness, so you set it to a lower percentage and then calculate the clusters. And you can also play around with different clustering methods to see which one will give you the most meaningful results. And then there is also this feature of the regions that are highlighted in the map. These are the pilot regions of the Polyrural project. And for these regions, we implemented an extended geo-report. It's also on the next slide, please. So for every region in Europe, we implemented the geo-report. When you click on there, you will see, we will be able to access that table that you can see on the lower section of the picture. And here you can read the data we have for every region. So this is for all regions. But then for the pilot regions, we also added some more qualitative and in-depth information about these regions. And this is the part with the text in the upper part. And next slide then. So we got some steps forward in the improvement and development of our web application during the hackathon, but we also have still many plans for the future for further development. So first of all, we want to have the rural attractiveness and the clusters in one single application, again, to merge that. We want to collect more data and better data. We want to try out and implement new methods to calculate clusters and the rural attractiveness index to get more meaningful results. We will want to continue on working the way things are displayed and on the functionalities of the application. And last but not least, we want to cooperate with the people from Challenge 3 and use their QGIS plugin to publish thematic maps. And yeah, I think this was mentioned already that there's quite some collaboration going on. Yeah, and next slide will be the last slide. Just, yeah, for me to thank you for your attention.
Thank you. Thank you, Sarah. Do we have any questions for Sarah? No. We are a little bit behind. Yeah. Do you have questions?
Many people are leaving now cities and trying to find some places to live in rural areas. Does your web application give information about real estate being sold in rural areas now?
No, it does not have such up-to-date information at the moment, but it could be a feature that we could include in the future.
Okay. Thank you.
Yes, Ivana, did you have a question?
Yes, so I'm curious to know who are primary users so far of the web application. So who is your target group, and if you were able to identify these groups, who is approaching this application the most?
So what we were thinking about is more really like decision makers and planners, but of course, I mean, also an individual being interested in, not now, but later, okay, where do I want to go on vacation could also be something like, or also people considering on where to move, they can also use that map to see, okay, where do I have a nice place to go to? So in terms of approaching these people, well, we had the people that were in the hackathon. So we had really approached certain people and asked them to participate in the hackathon. And yeah, in this way we approached, and they were planners and decision makers and these people. So yeah.
Okay.
Okay. Thank you, Sarah. I am looking for Righties because Righties is the one who is going to present the next challenge, number 5. I saw Righties was in here, but not now. It looks like maybe taking a break. Righties. I think Hannah, can you help getting the attention of Righties? Righties, yes, raise your hand. Righties is here. Okay, good. I need then to excuse Sarah. And Righties is coming in. Challenge number 5 is on the agenda now. So let's see. Which is a whiteboard and
hello.
Hello? Something funny happened with the screen here.
Yeah. Do you see me and hear me?
We hear you, but I don't see you.
At least I see myself in the video window.
Oh, there it is. Okay, thank you. Yeah. Okay, Righties, go ahead and share the results.
Yeah, sharing the screen.
Yes.
You see it, right?
Yes.
Yeah. Hello again. I will be presenting the challenge number 5, collaborative map making. And we were 3 mentors there and 3 developers, and some of the mentors were also developers. So the application or the library was started by Runar from Avinet, and then continued by me and Ailis Langauskis. Oops, I lost my notes. A second. Sorry. Yeah. I will just give you some background of the application. We have become quite adept at creating data. Our satellite missions provide more data than anyone can process continuously and every day freely available to the service of humanity. So Landsat was, of course, a forerunner, but it's, of course, important for me to show also the Sentinel-2, or at least the, what in the mind of Google it looks like. We have also become quite good at creating data together. The OpenStreetMap is sufficient to replace alternative map sources in many cases, and this is progress. These are problems solved, but once big problems have been solved, new ones appear, albeit perhaps smaller and less significant ones. And we still believe there is room for some enhancements, and we will try to demonstrate that. There are things that haven't changed much in the last 40 years or so. And if 2020 has taught us anything, except that when it rains, it really pours, it is that a lot of physical meetings are now hopefully and hopefully will also remain non-essential. Even the most avid opposers of progress have been forced to find some way to live in peaceful coexistence with web conferencing and collaborative platforms. And sharing maps rather than just data and enabling client-to-client map data creation allow for qualitatively richer and more efficient online experience. So in the images, you can see a process of collaborative map making in a physical space. And what I'm going to present is based on two different things. Map compositions, which Pavel Hayek already described in quite a length, so I will not be spending too much time on that. But the thing which we have been developing in this challenge is map whiteboards, which I will be going through a little bit more and also showing a demo. So map compositions can be looked upon as a way to store and exchange a stacked list of layers, which in the whole comprises a map which can be showed to the user or to some interested person. And why did we want a map whiteboard? Well, there are multiple reasons. From the early days of IoT, GPS transponders on trucks and taxis were allowing fleet control, and it looks neat if you have a fleet, but also pleasing in a way to those who were just captivated by how the technology works and how it looks. And more relevant to our lives, we had collaboration. We were writing large numbers of large documents collaboratively using Google Docs. And joint editing and authoring used to be a nightmare previously, and sometimes it still is. But with the advent of those Google Docs and similar platforms, multiple people could work simultaneously and also forego editing conflicts. Welcome was the concept of collaboratively shaping text, and growth of these solutions allow users to create their own content, and that's a very, very exciting thing. The model of these were to create your own working space, fill that space with your own data at your own pace, and then decide whether to share it with anyone. And of course, after reloading the web browser, the data still has to be there. So what we are aiming to do in this challenge is to create a Google Docs for maps. It could be summed up in a sentence like this. And about the map composition, it can be viewed as a project file, which is used for annotating the layers the map has, and its beginnings were quite humble. We just needed a way to store the map context between the page reloads of some application. And this technology is used in the web applications which we are building upon Aegis layers. And as Pavel already mentioned, it can be also used by QGIS plugin to create and annotate maps and then send and store them in some database which is managed by layman. And then the metadata can be described by Mitska metadata catalog. But in the map whiteboard context, we are using that to have a composition or working space which is linked to the some models which we are describing in the Polyrural project to describe policies and how they interact with each other, and model this policy process, which is used, for example, in planning regions. And I will show you a video how the map whiteboard library works. So when one user moves his mouse in one window, it's immediately visible on the other window. And these windows can be on the same computer in this case, but usually they are on separate computers and separate networks. And the users are able to switch layers and then draw features on those layers. And the layers and their features get sent to the server and then stored there. And it works close to real time with as less a delay as possible. Basically, delay is only dependent on the network conditions which the users are experiencing. And in this case, the Polyrural modeler is an application which already runs in production, though it's still being tested and some features are still developed on that. But the map whiteboard library has been completely integrated into this application. So I will show now a simplified technical architecture. So each client application or client browser integrates the map whiteboard library, which is a JavaScript library integratable in any mapping application, which runs on top of open layers. Well, in this case, we are developing our own application, our own library named Aegis layers. And we have multiple clients that can be connected this way. And by running a function, map whiteboard functionality is added to this map object. And then the map object then connects to a map whiteboard server over WebSockets, which are technology to develop close to real-time both ways communication between different web browsers.
Right.
Then,
can you speed up, you think, a little bit?
Yes, I just have like 5 slides, and I will just quickly go through those. And underneath the application serializes the features to GeoJSON and then sends it to the server, and then the features are stored in some persistent database. We use MongoDB because it has low latency, and since we are using WebSockets for low latency, we also should use database storage with low latency to just provide a good user experience. This is the architecture of the server-side components, which was developed in during the hackathon. You can see 2 databases and 2 server endpoints for sending and receiving data, and also a front end. But I will not go in more detail through that. We created some documentation and diagrams which describe the whole process of synchronization of map compositions, and also user authentication, which is done in a similar way to OAuth authentication, where the 2 separate server components, namely Map Whiteboard and the container application for polyrural modeler, are then using the same authentication endpoint. Also there is a diagram explaining the feature propagation. When the Map Whiteboard sends a feature which the user has drawn on the map to the server, then it gets automatically propagated to all the clients which currently have opened the same map composition in their browsers, except the original author, of course, not to get duplicates. And to make things short, I will then go to the results slide. So we have developed the mapping whiteboard library, which is open source. And it also consists of the client side and the server side application and a database. We have integrated that into the polyrural policy modeler tool, which is available in this link. And there's also a screenshot of it. And well, it still needs some work. It's in a late prototype stage still, but it's already usable, and some partial documentation has been created for that. And the potential usage areas could be crisis management, where you need to draw some map content in a collaborative and real-time manner, and probably also agriculture, where you would need to digitize some raster images to vector features collaboratively, and also different forms of planning, which I was mentioning and also describing in the container application for polyrural. And also, of course, it can be a meeting aid, because the Map Whiteboard library is a general purpose tool and can be integrated in any other mapping application. Could be also useful for education, for example, and data capturing. So that's all from me. Thank you for your attention, and I will be happy to answer any questions you have.
Thank you very much, Aitis. It's interesting, but the time is running. We are about 15 minutes late, I think. The jury, do you have any questions for Aitis? It was very technical in this presentation, but you might have some questions. No, everything is clear. You made it clear, right? You made it very clear. Thank you so much. And I will escort you out of down from the stage. And we will invite Antoine. Antoine, are you ready to join us? This is very exciting. We haven't tested with Antoine yet this tool, so we will see you. I just approved you raised your hand, Antoine, and I approved your, or I invited you in to the webinar room. We have a backup, but let's see. And for those of you who are still here, thank you for staying on. We have very shortly after Antoine has done his presentation, we will post the poll so that you can participate in the popular vote for your favorite challenge or results in this hackathon. While we are waiting a little bit for Antoine, I will remind then you, Tula, you are our backup. I learned. So, okay, let's see. Antoine, I will invite you again. It might be that you have the technical setup is not allowing you to get in. I will try once more. Otherwise, Tula, can you please also raise your hand so that I can invite you in to do the presentation of challenge number 8 about indigenous people. Let me see here if I have. Yes, Tula, thank you. Could you just raise your hand, Tula, so we if not, Antoine is making it in. I think I know that this might be a technical problem. So I will ask you to do this right now in the interest of time. Sorry about this, Antoine. And thank you, Tula, for agreeing to step in. So, yes, we have the popular vote immediately after the presentation of this last challenge results. And so you will be able to join us, to participate in that. Ah, Tula, you're in.
Am I?
Yes, well, with your voice.
Thank you.
Camera on as well, so we can see you.
Okay. My camera is where? There.
There it is.
Okay.
Hi. Nice to see you.
Nice to see you all. So, shall I start?
Yes, go ahead and start. And if you can be brief, we would really appreciate it because, as you know, we are a little bit behind the time.
I'm always very brief. No long words from my side.
You're finished.
I hope you can see something. What do you see now?
We see one big slide and one small slide. So I think you have this.
Well, maybe we can do it in this way. Yes. Okay. You can see 2 slides at the same side. So this is very brief presentation. Anyways, challenge 8, digitalization of indigenous knowledge. It's a difficult word for me. That's why I used traditional knowledge. Knowledge about history. How was things before and how things are now? That's something to do with this case. We had about, well, more than 30 guys registered. I wanted to give some floor for these guys, which are in the first slide, because they were very key persons, very important persons in this case. And as you can see, we had guys from Europe and above all, very good friends from Africa. So the cooperation was very fruitful indeed. And what we did actually is that we tried to figure out how to collect information of good historical traditional practices, which are still perhaps useful, but anyways represent the agricultural world in Africa. how we can collect data, how we can sense the data, and how we can share the data. So digital format, and in this case, maps were in a center role. The method to do this hackathon was in 4 steps. We planned, we built, we measured the results, and we thought about learnings. In the plan phase, we used quite a lot of time to think about what is indigenous knowledge, what kind of examples we could bring into this hackathon. And by different discussions, meetings, we decided to go with 2 pathways: food storage methods that prevent waste in grains, and we decided to map out microorganisms in soil. Very different cases, but it seems to be important to save this kind of information for the future. The phases, I mean, the green boxes show how we are going to tackle this challenge. Phase 1, what to collect. Phase 2, how to collect the data. Phase 3, is it valuable information? And phase 4, how to share the information. Pathway 1, food storage methods. And surprisingly, we use the same technology as has been seen several times already in this afternoon, but it works. It works also in this case. We didn't collect many examples of food storage methods in Africa, but we tested the system and it works very nicely. We have 4 examples from Africa, and just for the test case, we had 1 from Finland. So that's why we have this house from Finland. Maybe we have more yield than in Africa. So we had a platform, we found data, and we shared the data by using map and this platform. That was pathway 1. And then pathway 2. I couldn't, before this case, thought that microorganism is something indigenous data, but it is, because they are something in soil. They have been there for decades, and it's very important in order to save biodiversity environment that we save these microorganisms for the future. So we started from mapping areas in Uganda where is evidence that the original microorganisms are still there. And as far as I understand the map correctly, the forest areas are the most richest areas when we talk about microorganisms. And before this, there were no map. So this is the first digital map, thanks to Pavel Hayek, that is made to describe the location of certain microorganism families, how to say. And the great thing is that the idea of a data bank is coming closer. Think about that. How to create a data bank of Africa of microorganisms. Now we have a tool to describe where it is. We are pretty close to do some next steps to serve something very original of Africa microorganism. Yes. So, what we learned. Food storage first. There are no much documented data about storage systems in Africa. That's the fact. And now we have a system and methodology to do that. Well, maybe we don't have resources to do that, but that's another story then. So there are options and possibilities to go on with the pathway 1. Pathway 2, as I said, the regional, even national data banks for microbial resources is something very valuable. It's a great idea from my point of view. Need some effort indeed. About the teamwork, we had guys from many countries. We had different kind of connection systems, channels. We reached it practically, let's say 10 to 15 guys which were more active. And I was very, very pleased that we got a lot of support from Challenge 3 and Challenge 6 to make this happen. So I need to thank all who supported and contributed to this challenge. Thank God we are in the end. Thank you.
Thank you so much, Tula. Thank you for stepping in to the webinar room on the stage. Do we have a quick questions? I know that the jury is short on time, and we are all I think happy to leave the screen for a while now. So do you have any questions for challenge number 8 for Tula? You're muted, Beata. No, we cannot hear you. Okay. And Mari's left the room. Okay, I think, Beata, maybe you can write it in the chat. Maybe you can write a question in the chat. And while you are doing that, I will, while Beata is writing, no, we cannot still not hear you. No.
Later on.
Later on. Yes, we will have a jury duty break now. Thank you so much. Thank you so much, Tula. I will escort you off the stage as well, and I will invite Hannah. Maybe she will be able to join us now. Thank you, Tula. Thank you so much.
Thank you. Bye-bye.
Right. Just so you know, Antoine, there is a special, there are a stage inside this room. This is a stage which is different from being an attendee, just so you know. She can write, yes, Antoine. Okay, Hannah, we will give a try now. It's very exciting to see if she can enter the room. Sometimes the technology is not cooperative. And you never know exactly what is stopping. So let's see if Hannah can join us. No, not yet. I will, while we are waiting, publish the poll. So now you have been given the possibility to score or let us know which one is your favorite challenge presentation. It's very informal, of course. No, it doesn't work. I'm so sorry. I'm very sorry that you don't get to meet Hannah. If you haven't done it already, you missed out. I'm sorry for that. Okay, so the jury will retire to the jury duty room. You have a Skype call that you can enter. Stay in the room here as agreed. And in here for the rest of us, I hope we will be done with this in approximately 5 minutes, 6 minutes, maybe. So 15:35, we are ambitious trying to get back here in here. For the audience, please stay on until then. If you, we will have a ceremony afterwards. Also, when we know the results. It's online. Unfortunately, there cannot be the full-blown celebration that we normally do, but at least we will have something to announce the winners when the jury come back here again. Meanwhile, I hope if you haven't been attending or being a part of the hackathon, any of the Inspire hackathons yet, I hope that this was inspiring for you, that you can see that this is a community, that we were, like Carol mentioned in the chat, we see that the results from projects are being used and built upon and taken up by other users inside this the framework of the Inspire Hackathon. We have also heard several times that there are some cross-pollination that allows the participants to enjoy the resources across all the different challenges. So with that, I will show, meanwhile, while we are discussing with the jury, I will show you some videos from way back when we can actually meet, because normally the Inspire Hackathons is so that we having this virtual part, just like now, and then we finally meet and have the ceremony and presentations in a physical meeting. So this, we have some videos that I will share with you that you can see how that is, and we will think about how the future will be when this COVID-19 is over and done with and we can finally meet again. So enjoy the videos that I have.